Hello everyone, you're welcome to today's class. In our last class, we talked about the types of water, which are soft water and hard water. And we did establish that soft water are water that forms lather easily with soap, while hard water does not. And we went on further to look at the hardness of water, and we saw that there are dissolved salts that are responsible for its hardness, which are calcium tetraoxosulfate 6 or magnesium tetraoxosulfate 6 and calcium hydrogen trioxocarbonate 4. It is pertinent to note that what I explained in hardness of water is a general principle. So in today's class, we are going to be looking at the types of hardness of water. We have two types of hardness of water. They are, one, the temporal hardness, two, permanent hardness. So we look at the temporal hardness. This is as a result of the presence of dissolved calcium hydrogen trioxocarbonate 4, which decomposes on heating. So in this case, we have the substance that is responsible for its temporal hardness, which is this. And when this man is heated, it decomposes to give us, we have calcium trioxocarbonate 4. Was that, and the calcium trioxocarbonate 4 is insoluble. If you recall, you discover that this was what I explained when water acquires its hardness when it is dissolved from the soil. And remember, when it was dissolved from the soil, it was dissolved as calcium trioxocarbonate 4 with carbon 4 oxide dissolved in that water to give us the calcium hydrogen trioxocarbonate 4. Now, in this case, how do we take care of the temporal hardness? How do we remove the calcium ion from that water to make it useful for our use? One, we are going to look at the removal of hardness. And in this removal of hardness, the first is we are going to look at boiling. Now remember, we did say that calcium hydrogen trioxocarbonate 4 decomposes on heating. So in other words, if you boil that water, it will decompose the calcium hydrogen trioxocarbonate 4 in that water to make that water be useful for use. But however, this method is not economical because it means that you have to boil a large quantity of water to be able to use it in the nearest future. Now, if you take calcium, I've explained that earlier, so that is going to give us the same solution we have up there to give you calcium trioxocarbonate 4, and you have that and this. This one is soluble. So in this case, if you add your soap to it, what the soap does is to replace the calcium ion, that is, take the calcium ion away, right, and to give you a soluble form of that water to form lather. Now remember that the essence of all of these is for us to be able to form lather for use. Now the second method for our removal is the addition of slaked lime. Addition of slaked lime. Now, what is slaked lime? Slaked lime is simply a calcium hydroxide. That is your slaked lime. Now, if you add that to water, what it will do is that it's going to replace it's going to remove more of the calcium, I beg your pardon, it's going to remove more of the calcium ions to form an insoluble compound of that. And of course, we will have a soluble compound of the result to form ladder. Now, however, in this reaction, you have to take precaution. In the addition of slate lime is a calculated amount, that is, you do not add it in excess. Because if you add excess of calcium hydroxide, or rather excess of the slate lime, what happens is that you will convert that temporal hardness to permanent hardness, which is going to take a lot for you to redeem in the nearest future. So what will happen is that if you add excess of slate lime, we will convert the temporal hardness to permanent hardness. So one must be very careful when using that method. Now the next is, let's look at the effects of temporal hardness. So let's look at the effects of temporal hardness. One of the effects that you can have is the thawing of kettles. Or boilers. Now, boilers are what we call boiling ring. I don't know if you have seen a boiling ring before, but of course, if you have not seen it, we just refer to them as boilers. Now, remember, what is the principle of removing the hardness? One of them is that we use boiling. So if you have water in your kettle, of course, the principle there will be boiling, or the boiler will be the one connected to an electric source to result in boiling. Now the essence is actually to remove the insoluble calcium trioxocarbonate 4. Now when this is done, if you look at the internal surfaces, the surface of the kettle or the surface of the boiler, you discover that there's a whitish deposit. And that whitish deposit is calcium trioxocarbonate 4 because it is insoluble. So that whitish deposit can cause the thawing. That is, the thawing is that it coats it such as it wants to look like it's rusting, like that of an iron, but it's not actually rusting. It's something that is just whitish on the inner part of it. So if you add water to it, if you are not very careful, this same calcium trioxocarbonate 4 will affect the next batch of water you want to boil. Now the second one we have is the formation of stalactites. Stalactites and stalagmites. Now this happens in caves. I don't know, they must have mentioned it in your geography, but I'm not your geography teacher, but I'll just give you the chemical composition of what forms the stalactites and the stalagmites in caves, in hot caves. Now when you have a cave that is hot, what happens is that when water runs on the top roof of that cave and you have cracks on that cave, the water seeps into the cave. And because the cave is hot, there is an heat generated in that cave, and that has the ability to decompose the calcium hydrogen trioxocarbonate 4 to give you the insoluble calcium trioxocarbonate 4. Now, stalactites and stalagmites are formed as a result of the deposition of calcium trioxocarbonate 4. Now, you will want to ask, what are the stalactites and what are the stalagmites? Now, the stalactites, if I have this as a structure of the cave, I'm not a good drawer, but I'll just give you an instance. Let's say this is ground level, and you have your cave such as this. Right? When water seeps on that cave, you begin to see formation such as this. I don't know if you have seen them in documentaries. I have. You see growth of this nature. And sometimes you have the growth from the rooftop coming to meet the growth from the ground floor. These ones that grows from the rooftop are what we call the stalactites. And these ones that grows from the ground floor are what we call the stalagmites. So in other words, you can have the stalactites and the stalagmites coming together to form a pillar in that cave. And the substance that is responsible for that is calcium trioxocarbonate 4, which results from the decomposition of calcium hydrogen trioxocarbonate 4. At this point, I'm going to draw the lesson close. If you have any questions, you send them to my private chat. Thank you for listening.